Welcome back to Summarize Science. Today, we're diving into the dramatic and sometimes violent lives of cosmic spiders, a special type of star system where one star slowly devours its partner. These aren't actual spiders, of course, but binary star systems containing a superdense neutron star, also known as a pulsar, and a more normal companion star. Initially, the pulsar pulls material from its companion, spinning itself up to incredible speeds. Then, the tables turn and the now supercharged pulsar starts blasting its companion with intense radiation, slowly stripping it away. Astronomers have classified these systems into groups like Black Widows and Redbacks based on the size of the poor companion star. But recently, a new, mysterious group called Huntsman Pulsars was discovered. These Huntsman systems are like Redbacks, but they have orbits that are 10 times larger, which was a real puzzle. A new paper, Formation and Nature of Huntsman Binary Pulsars, set out to solve this mystery using complex computer simulations. The researchers found a fascinating explanation hidden in the life cycle of the companion star. There's a specific phase where the star, after running out of fuel in its core, starts burning hydrogen in an outer shell. This causes a temporary hiccup in its evolution, making the star briefly shrink and pull away from the pulsar. This detachment phase, which lasts a few million years, is what they believe creates the Huntsman systems we see. Looking at their models on this graph, the blue and pink dots represent exactly where the models predict these Huntsman systems should exist. And incredibly, the two known Huntsman systems fit right into this predicted zone. What's really interesting is that this Huntsman state was actually an implicit prediction in the researchers' previous work. They just hadn't specifically identified it yet. The research also showed that the radiation from the pulsar that creates redbacks and the internal nuclear process that creates Huntsman systems are separate events. They can happen in the same system without interfering with each other, meaning a star system could be a redback and later pass through a Huntsman phase. This chart shows how a single system can experience both types of events, the pulses driven by radiation feedback and the big dip caused by the internal hydrogen shell burning. So, to recap the key points, Huntsman pulsars are not a weird, separate class, but a predictable, temporary stage in the life of some spider pulsar systems. This stage happens when the companion star temporarily shrinks due to a change in how it burns its fuel, causing a brief detachment from the pulsar. This finding helps build a more complete, unified story of how these fascinating spider systems evolve over billions of years. What does this mean for the future? It provides a clear roadmap for astronomers to find more Huntsman systems, as they now know exactly what signs to look for. The models also predict where to find them at different metallicities, expanding the search across the galaxy. Each new discovery will help us refine our understanding of how stars live, die, and interact in these extreme cosmic dances. That's all for today on Summarize Science. Thanks for watching.